Great, our last graph here on the review is cotangent. Cotangent is kind of tricky just because it's not one that we graph a lot. Again, the period of cotangent is pi, so I'm going to go ahead and make a note of that, just like I did with the tangent graph, so I don't get in the middle of it and make a mistake. The other thing is cotangent has asymptotes where tangent has points. So tangent usually, or where tangent has x-intercepts. So tangent has x-intercepts on the y-axis and at pi. So I think that's helpful. If you even need to graph tangent off to the side, kind of, asymptote, asymptote, graph. Or, sorry, that's the reflection, graph, graph. And that's 0, 0, and that's pi 0. So I think that's kind of helpful to look back at tangent so that you can see where, so our asymptotes are going to be at 0 and pi because that's where our x-intercepts were for tangent. The parent function then for cotangent goes in the opposite direction, so it's decreasing instead of increasing. So I think having that parent function there for you to look at is really helpful. Cotangent is a little bit trickier. So we have 7/2 in front, so that means those two little spots that are going to be halfway in between your x-intercept and your asymptotes are going to be at 7/2 instead of at 1. And so that's that dealt with. And again, just like the tangent problem, we could write that as a 1/2 x. So a 1/2 is what we're dividing pi by to figure out the period of our function. So if you want to do flip the second and multiply, that's great. Pi over 1 times 2 over 1. So the period of our function is 2 pi. So we're going to take that normal cotangent function and stretch that asymptote at pi out to 2 pi. That does not affect the asymptote that lives on the y-axis. Only thing that would affect that one would be a phase shift. So pi is 4 units out. 2 pi is going to be 4 more units out. We're going to have a x-intercept at pi. At pi over 2, we're going to go up to 7/2, which is 3.5. And at 3 pi over 2, we're going to go down to negative 3.5. Graph at least 2 periods, so we're going to keep going here, 8 spaces out. And just repeat that same pattern. All of these functions can be broken into fourths. I think that's really the easiest way to graph them, whether you're doing tangent or cotangent or sine or cosine. So we had no vertical displacement, we had no reflection, we had no phase shift. Woo, this one was too easy. Our asymptotes here are at 0 and 2 pi, and if our period is 2 pi, that means this other asymptote's at 4 pi. So that's, having those listed is going to really help you with your domain. So we're going to do pi n, because our 2 pi n, because 2 pi is where our first positive asymptote is. And then you can say where n is an integer. Two pi times 1, 2 pi times 2, sorry about the bell, 2 pi times 3. The other way you could write that is pi n, x cannot equal pi n, where n is even. So 2 ways to write that domain, either way would be correct. And of course our range is all of this.